What does vector mean? It comes from Latin. It means something that carries or conveys something else. You may have heard of this term in biology. For example, the Anopheles mosquito is a vector for malaria. It carries malaria. In physics, vectors are quantities that take something somewhere. So you can say that something that has a magnitude and a direction is a vector. What are some examples of vectors? Force is a vector. Magnetic and electrical fields are vectors. The polarization of a wave is a vector quantity. How do we denote vectors in physics? There are two popular ways. One is using boldface, so you write down the vector quantity, the first letter in bold, or the more common method is to use a small arrow mark above the letter used to denote the vector. Vectors are spatial. They are dealing with the physical directions that we encounter in the real world. But in order to define direction effectively, we first have to define the space within which that direction is being used. For this class, we will use the Cartesian space or Cartesian coordinates, which you are already somewhat familiar with. Let's consider a 2D space. This is a space that is defined in terms of two orthogonal axes. The vector has a beginning, that is the tail, and a termination, that is the head. And in addition, in 2D space, a vector points to a point in that space that can be defined by two unique numbers. In 3D space, we have three orthogonal axes which are used to define every point in that space. And unlike a 2D space where all the vectors exist in a single plane, a 3D space contains many different planes. Also, just as in the case of a 2D system where we needed two numbers to define a point, in a 3D system we require three numbers to uniquely define any point in that space. So let us look at this figure to understand the structure of a vector. This is the head of the vector, that is the termination of the vector, and this is the tail of the vector or the origin of the vector. To determine the magnitude of this vector, which is the length of the vector, we subtract the coordinates of the tail from the coordinates of the head. So how do we determine the direction of a vector? The direction of a vector is simply the angle the vector is making with the horizontal axis in our convention. More specifically, the ratio of the vertical rise of this vector over the horizontal run of this vector gives us the tangent ratio of the angle for this vector. So what is the difference between vector quantities and quantities that possess no directional properties? This is the question that we will answer next. So let's summarize what we have learned so far.
Manorama Horizon. Learning made simple.